Now that we've learned how to solve systems of equations using graphing, substitution, and elimination, and we do graphing and elimination on our graphing calculator, we're going to learn how to do application problems with these systems. So you will need your note packet, and we're going to be on page 1 and 2. These application problems are going to be word problems. So this first problem says the sum of two numbers is 30. So a couple things that we need to recognize is that sum is going to mean to add. And when we see the word is, that typically means equals. And then it also says, and their difference is 12. So this time, difference means subtract. Again, I see is, so that means equals. And then it says, find the two numbers. So we need to write two different equations. So right now I have two numbers. I don't know what the numbers are, so I want to use variables, and I might just use x and y. Rereading the first sentence, it says the sum of two numbers is 30. So if I add the two numbers together, my total is 30. The second sentence says their difference is 12. So again, I'm going to use x and y. I don't know the numbers. If I subtract them, I get 12. If I look at these two equations and I think about my flowchart we used last week, I see that they're both not solved for y, so I'm not going to use graphing. I don't have either of them with the variable isolated, like x equals by itself or y equals by itself. So this tells me that I should solve this using elimination. And remember, we just use elimination on the graphing calculator now. So I want to enter a matrix. So I would go to my calculator and enter a matrix. This matrix is 2 rows by 3 columns. So I enter that in the dimensions. And when I enter my numbers, it would look like this. So I have 1x, 1y equals 30, 1x, negative 1y equals 12. So go ahead and take a second and type that into your calculator, solve your matrix, and see what you get as an answer. Once you get this entered on your calculator, you should see this on your screen. And so again, that means that your x is 21, your y is 9, and so these two numbers are 21 and 9. So if you think back to our original problem, it says the sum of the two numbers is 30, so 21 plus 9 is 30, and their difference is 12. 21 minus 9 is 12. So we're going to try another one of these. This time it says one number is 4 times another number, and their sum is 175. So I'm going to start with the second sentence first. So it says sum. I know that that means add. I don't know what the two numbers are. So again, I'm going to use x and y. And this basically tells me when I add x and y, the total is 175. Going back to the first sentence, it says one number is 4 times another number. So that means that x is, so that means equals, 4 times the other number, so 4 times y. So x is 4 times y. So here's my two equations. I know I'm not going to be using graphing because I don't have both of them as y equals, but I do have this second equation. I have x isolated. And so that tells me I'm going to use substitution. Substitution is the only one that we can't use our graphing calculator for, so we're going to have to do this one by hand. Remember, when we do substitution, we are taking this 4y and we are plugging it in anywhere we see an x. So I'm going to plug it in right here. So instead of x, I'm going to write 4y. Then I just continue the equation. Plus y equals 175. 4y plus y is 5y. I divide both sides by 5, and I get that y is 35. I still need x, so I'm going to have to plug it back in. I'm going to plug it back into the second one that I highlighted just because I think it's a little easier. So I'm just going to plug in y. So I have 4 times 35, which gives me an x value of 140. So in this case, my two numbers are 140 and 35. On this example, it says a delivery truck arrives at a store with 8 small boxes and 5 large boxes. The total charge of the boxes without tax or delivery is $184. A large box costs 3 more than a small box. What is the cost of each box? So if I start with my first sentence, I have 8 small and 5 large, and the total is going to be $184. So that tells me that I'm adding these together. Then it also says a large box costs 3 more than a small box. So large is 3 more than a small. So the more than tells me to add. If you think about it, I used S and L just to help me remember, but this is sort of like my X, and L is kind of just like my Y. So if you think back to our flow chart, I don't have both equations solved for Y, so I'm not going to be using graphing, but I do have this second equation. I have a variable isolated, and so that would tell me to use substitution. So again, we have to do substitution by hand. So I'm going to take this S plus 3 and plug it in where this L is. And remember, when we plug things in, we want to put them in parentheses. And that tells me right here that I need to distribute. Then I can combine my like terms. And so I have 8s plus 5s, which gives me 13s. I can subtract 15 from both sides. I'm going to go ahead and rewrite this over here. So I have 13s equals 169. And when I divide both sides by 13, I get 13 for S. So I have 13 small boxes. Then I'm going to use that second equation and plug in my S to figure out how many large boxes, and I get 16. So that, as an ordered pair, is 13, 16. Or if you like to write it out, that's 13 small and 16 large. Either way would be okay. Take a couple seconds and try to write the equations for this example. So go ahead and pause the video, take some time, try to write your 2 equations. And then once you have them written, figure out which method you would use to solve. So if you read this, it says at a business meeting at Panera Bread, the bill without tax for 2 cappuccinos and 3 lattes was $14.55. So there's your first equation. So 2 cappuccinos plus 3 lattes equals $14.55. If you continue reading, it says at another table, the bill for 1 cappuccino and 2 lattes was $8.77. So your second equation, 1 cappuccino plus 2 lattes equals $8.77. So hopefully you figured out those are your 2 equations. The next thing you should have looked at is, how are we going to solve this? So again, these C's are the same as my X's, These L's are kind of just like my Y's. I don't have both equations solved for Y, so I'm not going to use graphing. I also don't have either equation. I don't have a variable isolated, so that should tell me that I need to use elimination. And remember, when we do elimination, we're just going to use our graphing calculator. So go ahead and pause this. Take a couple seconds to solve the system using your calculator, and then we'll unpause and see how we did. After you enter your matrix in your calculator and solve, you should see 2.79 and 2.99 as your answer. And so, again, you can write it as an ordered pair, but what this means is that it's $2.79 for a cappuccino, and it was $2.99 for a latte. In this example, it says, in one day, a business sold 22 aglets. The large aglets sell for 20 cents. The small aglets sell for 10 cents. The total income for the day was $3.20. How many of each were sold? So I know I'm going to kind of ignore the first sentence and start with the second part. So it says large aglets sell for 20 cents. So I know that it's 20 cents for a large, it's 10 cents for a small, and the total sales, so I'm adding that, were $3.20. I also know from the first sentence they sold 22 total. So that means however many large they sold plus however many small they sold was 22 total. So that's where my two equations come from. Again, I can just kind of say this was like an X, this is like my Y. I am not going to do graphing because nothing is solved for Y. I'm not going to do substitution because I don't have one isolated variable. So again, this is another elimination problem. So go ahead and try again to solve this using your graphing calculator. After you've entered this in your calculator, you should see this as your answer, which tells us that they sold 10 large and 12 small. And so if we write that as an ordered pair, it would have been 10, 12. This next example is really similar to the last one. So it says a student has some $1 and $5 bills in his wallet. He has a total of 15 bills that are worth $47. How many of each type of bill does he have? So go ahead and take a couple seconds to write your two equations and then also figure out what method you would use to solve. So pause the video, attempt this one, and then we'll check in and see how you did. So hopefully for this one, you see that you have $1 bills, $5 bills, and a total of $47. So I have 1x plus 5y, and that equals $47. I also know that I have a total of 15 bills. So however many ones I have plus however many fives I have equals 15 total. Then I don't have either equation solved for y, so no graphing. I don't have either variable isolated for either equation, so no substitution. And so you should have chosen elimination. So again, go ahead and pause this, enter your matrix into your calculator, and get an answer for this system. After you input this into your calculator, you should see the following answer show up on your screen. So my answer as an ordered pair would be 7, 8, and what that meant was I would have 7 $1 bills, and I would have 8 $5 bills. For this last example, it says at a school play, we have 129 tickets sold. Adult tickets cost $1.50. Children's tickets cost 75 cents. In all, $153 was taken in. How many of each kind were sold? So go ahead and attempt this entire problem by yourself. Write your equations, choose a method, solve it. We'll pause this video for a little while and then we'll show you the answer in a second. I'm going to start with the blue highlighted portion. So I know that adult tickets cost $1.50. So I'm going to use A for adult. Children's tickets cost 75 cents. So I'm going to use C for children. And a total of $153 was made. I also know that we sold 129 tickets. So however many adult tickets plus my children tickets, the total was 129 total tickets. So there's my two equations. Again, I used A and C to just help me out, but you could have said that this was X and this was Y. If I start looking at what method to use, you should have said this would be an elimination problem, which means you just get to use your graphing calculator. Once you type your matrix into your graphing calculator, you would see 1, 0, 7, 5, and 0, 1, 54. So as an ordered pair, you could write it 75, 54. What it really means is we sold 75 adult tickets and we sold 54 children's tickets.